polynomials, we're dividing them using long division. It is a process. Make sure if you haven't practiced that process yet, I realize some of you might have been gone, so make sure you get caught up with that. But make sure you are practicing that process so you understand it. Today we're learning a process called synthetic division. So it is an alternative method to use. You might think of it, or it's kind of considered an easier method than long division. But the reason you still have to know long division is because long division always works. Synthetic division, while it might be easier, does not always work. So synthetic division works when you're dividing a polynomial by a binomial, but I'm going to add to that, it only works if the binomial is in the form of x minus some number r. So if you are dividing, say, by x squared minus 3, that is not in this form, synthetic division will not work. So long division does always work. Synthetic division is great when it does work, but doesn't always. It's kind of like the factoring process. Factoring doesn't always work. So that's why you still have to know long division. What this top part is talking about, we're not going to need this for example 1, but something that didn't come up yesterday, and it's going to come up on some of the examples on the back of the note sheet, is if your polynomial in the dividend, so what is being divided, if you're missing a term, a 0 must be used to represent the missing term. So for example, if you had this polynomial 2x cubed minus 4x squared plus 6, notice you want your powers of the variable to be going in decreasing order. So we have x cubed and then x squared. We don't have an x term, so a 0 would have to be used as a placeholder for the x term. So this is how it would be rewritten. 2x cubed minus 4x squared, you put a plus 0x in place of the x term, and then the constant of plus 6. So we don't have to worry about that in example 1, but we will talk about that later on. This is also true. This process is true for long division as well. We just didn't have to worry about it yesterday. So in example 1, I realize some of you might have been gone, so I will be walking around to help out in your groups, help each other out. I am going to go through example 1 twice with you. So we're going to do example 1 with long division, reviewing from yesterday, and then go through the process of synthetic division with the same example. So you see one example done both ways. Because we covered long division yesterday, I want you to do example 1 in your group. So if you need to, get your note sheet out from yesterday to review how to do it. Like I said, if you were gone, help each other out, but I'll be walking around as well, and divide those polynomials using long division. So review how to do this, because you need to know how to do it.
should be minus because to make it negative 2x squared, you would have to multiply by n like 2x. Yes, but make sure this is right, but it was distributed to both sides. So this would be minus 6x squared, and that was up down. Yeah. Here you have to be Yeah, so you're subtracting. However, 11 minus that, so that should be 7. We'll probably take more time.
All right. Double check what you have. There should not be a remainder, so it should just be 3x squared minus 2x plus 7. Okay, so what I want you to keep in mind with this, again, we did this in class yesterday, now looking at it today. If you hadn't done this practice yet and you're looking at it today thinking, okay, I understood it yesterday, but I am not confident with this, that is what the practice does. So make sure you're looking at that. You do have a homework quiz Monday, but just to be able to move forward in a chapter, you need to understand each lesson. As we build, you can't build on something that you don't understand yet. So let me know if you have further questions, but I do want to get us moving on to the synthetic division because that part is new. So synthetic division, these steps are here for your reference. I will reference them as we go through the same example. So we already know the answer we should be getting, but we're going to do it a different way. And then you can see how each process is a little different. So in synthetic division, what it says in the first step is mainly you have to know how to set it up. There's a setting up process to it. So you write the coefficients of your dividend. Your dividend is what's being divided. You write the coefficients of the dividend so that the degrees of the terms are in descending order. All that means is if you notice in your dividend, it goes x cubed and then x squared and then x and then your constant. So this is already written the correct way, but if it wasn't, you would rearrange it. It says write the constant r of the divisor x minus r in the box. So I will talk about what the box is because you're probably thinking, what is the box? And then you bring the first coefficient down. So your divisor in synthetic division always has to be in the form x minus some number r, because you have to then figure out what is r. So if we have a divisor of x minus 2, what is the r value? I heard someone say 2. So r is always going to be the opposite sign of how it appears in the actual divisor. If it's x minus 2, r is really positive 2. If it was x plus 2, r would really be negative. But you have to figure out what r is. This is what step 1 is explaining. This is how you set it up. You take your coefficients of your dividend. So that would be the 3, the minus 8, the 11, the minus 14. So you include the constant. And I'm just going to write those, leaving some kind of space in between, but write those in a line. And then in that same line, but to the left of the 3, so before the 3, I usually just make like a partial box. You could make a full box if you wanted to. That's where your r value goes. So I'm going to stick the 2 in there. And then you want to leave a space. You're going to be writing in the line that's kind of below the number. So leave a space and then draw a line because you're also going to be writing below. So you kind of need a space here and then the room to write below. And when it says bring the first coefficient down, the first coefficient of 3, you bring down below the line. So this is just the setup part of synthetic division. You have to understand how to set it up. And then from here, these next 3 steps, I'm not going to read word for word, but I will explain them as we go through this. They're just there for your reference if you need to look back at them. So from here, any number that is below the line, you multiply it by the r value. So I'm going to multiply the 3 by the r value of 2, and that's 6. The product then gets written in the next column. So below the negative 8, I would write a positive 6. So multiply the number below the line by r, write the product in the next column, and then you add these numbers in the column together. So negative 8 plus 6 is negative 2. The negative 2 gets written below the line. Okay, then you repeat. So now you do the same exact thing but with the negative 2. So negative 2 gets multiplied by 2. That's negative 4. Negative 4 gets written underneath the 11. I add the 11 and the negative 4, and that's 7. 7 goes below the line. Okay? Do it again. You do it until you're in the last column. 7 times 2 is 14. 14 goes below the negative 14. They're added together, and that's 0. Now, I usually will also draw a line before the last value because the last value is going to be your remainder. So we saw in the long division there was no remainder, so that's why it's 0. Do you see the 3, negative 2, and the 7 in the answer we got before? Okay, they are the coefficients of your answer. So once you're here, this is how you know how to write your answer. Whatever the highest power of your dividend was, the highest power in your answer is always 1 less. So the 3 is going to be the coefficient of an x squared term, because 3 was my highest power, now it's going to be 2. Negative 2 then, and then you go down decreasing order, so negative 2 would be the x term, 7 is the constant. So the answer is 3x squared minus 2x plus 7, and the remainder is 0. So that's how we could have gotten that same answer with synthetic division versus long division. So you saw the same example both ways. Okay? Any questions? Now, you can form your own opinion whether you think long division or synthetic division is easier. But like I said, synthetic division doesn't always work, so you still have to know how to do long division. It's just great when it does work, because I think a lot find it to be an easier process. It is, though, easy to make a mistake, so make sure you're really following your steps. We are going to go through example 2 and 3 also together, because each one has something slightly different. So in example 2, if you look at your dividend, 4a to the 4th plus 2a squared minus 4a plus 12, are there any terms, any powers of a that are missing? A 3, a to the 3rd is missing. You have to fill in that term with a 0 before you start, otherwise you will get the wrong answer. So I'm going to rewrite this. This is 4a to the 4th. Since I don't have an a to the 3rd term, I'm going to write plus 0a to the 3rd, and then fill in the rest that I do have, plus 2a squared minus 4a plus 12. So you always have to have every single power in descending order, and you also always have to have a constant. If there wasn't a constant, I would have to put a 0 there as well. Okay, and then I look at my divisor. It's a plus 2. This is in the form a minus r, because our variable is a. What is the r value? Negative 2, the opposite. So then I can set up my synthetic division, write out my coefficients. So those are 4, 0, 2, negative 4, and 12. And then in the box is my r value of negative 2. I can draw the line, and I can bring the first coefficient of 4 below the line. That's all just the setup part. Okay, then you do the synthetic division process. So the 4 below the line gets multiplied by the r of negative 2, that's negative 8. Negative 8 goes below the 0. They get added together. 0 plus negative 8 is negative 8. Repeat. Negative 8 times negative 2 is 16. That goes below the 2. They get added together, and that's 18. 18 times negative 2 is negative 36. That gets added to negative 4. That's negative 40. Negative 40 times negative 2 is 80. That gets added to 12, and that's 92. And then I'm just going to draw a line. The 92 is the remainder. Keep that there. So then you're ready to write your answer. So don't stop here. This is not your answer. Your answer should be a polynomial. And we do have a remainder with this one. So my first coefficient is 4, and it's going to be 4a to what power? The 3rd. So it's 1 power less than my original polynomial, what I started with. And then I go down in order. So then it would be minus 8a squared plus 18a minus 40. And then you write remainders the same way we did yesterday. So it would be plus, and it's always the remainder over the divisor. So the remainder is 92 over the divisor is a plus 2. And that would be how you find your quotient and remainder with synthetic division. Because when you divide, like this has a highest power of 4, when you divide by a power of 1, you're losing a power, you're going down a power. So it's your quotient will always start with 1, like the highest power will be 1 less than what you started with. All right, example 3. So you'll see another example I'll lead you through, but this one, the first one didn't have a remainder, the second one did, the third one may or may not have a remainder, but there's another thing that's different about it. So first of all, looking at your polynomial, are we missing any x terms? The third power again. We have x to the fourth and x to the second, but no x to the third. We have to fill in a 0. So it would be 8x to the fourth plus 0x cubed minus 4x squared plus x plus 4. I'm going to also write after that divided by the 2x plus 1. So I have more room to write this out. What is different about this one is look at your divisor. The divisor has to be in the form x minus r. The r value here is not -1 because there is a 2 in front of the x. In the x minus r form, the number in front of the x should just be a 1. There shouldn't be a different coefficient in front of x. So if you have a number in front of the x, you can still do synthetic division, but I have to get rid of this 2 by dividing by 2, but that means I divide every single term in both my dividend and divisor by 2. I have to divide everything by 2 first. So the 8x to the fourth gets divided by 2, everything does. And here's the thing, when you divide by 2, leaving it as a fraction is always okay if you're going to have fractions. Decimals are fine, again, if they terminate. So when you divide by 2, those are terminating decimals. If you want to write decimals in this example, it's fine. But otherwise, say we were dividing everything by 3, we would have to leave fractions. So just keep that in mind. Don't round any decimals. So when I rewrite this, I'm going to have 4x to the fourth plus, I'm still going to have 0x cubed minus 2x squared plus 1/2 x, or if you put 0.5x, that's fine, plus 2. And then that's divided by x plus 1/2. So now my divisor is in the correct form, and what is the r value? -1/2, or if you had -0.5, that's fine. So now when I set up my synthetic division, I'm using the one that I rewrote. So I'm using this line here, not the original. So my coefficients are 4, 0, -2, 1/2 or 0.5, and 2. And I have -1/2 or -0.5 in the box. And I can bring down the first coefficient of 4 right away. And if you left it as 1/2, or even if you changed it to 0.5, when you multiply by a half, you're really just dividing by 2. So we're really just dividing by -2 here. So 4 times -1/2 is going to be -2. That gets added to 0, so that's -2. -2 times -1/2 is +1. That gets added to -2, so that's -1. -1 times -1/2 is +1/2. And that gets added to 1/2, so that's 1. And then 1 times -1/2 is -1/2. And this is going to be our remainder. So 2 minus a half or plus -1/2 is going to be 1.5 or 1.5 or 3 halves if you kept it as a fraction. Either one's fine. So we can go ahead and write our answer, but when I write this out, it's still not going to be final. So make sure you don't box your answer yet. There's one other thing we're going to have to do. But when I write this out, I have 4x2 up power. Yep, 3 cubed, minus 2x squared, minus 1x, or just minus x, plus 1, plus my remainder of 1.5 over, and I have to write it over the x plus 1/2 right here, because that's what I was using, so I have to use the x plus 1/2. But I can't leave this as my final answer because all answers should be simplified. And when you have decimals or fractions in a fraction, it's not simplified. So this here, the 4x cubed all the way down to positive 1, this is fine. This is still part of your answer. We're not going to change that. We just have to change the fraction. So because I had to divide everything by 2 at the beginning, to get my fraction to not have fractions or decimals in it, I have to multiply the top and the bottom by 2. And make sure on the bottom the 2 is getting distributed. So what's going to happen is the denominator is going to change back to the 2x plus 1, but your numerator is also going to change to a whole number and not a decimal or a fraction. So final answer will be 4x cubed minus 2x squared minus x plus 1 plus, but now it's going to be a remainder of 3 over 2x plus 1. And now my fraction doesn't have decimals or fractions in it, so my answer is simplified. Okay, so it's a bit more of a process if there's a number in front of x, but you can still do the synthetic division. Just make sure you're working through it the correct way. Are there questions on that one? Okay, I want you to do example 4. So use synthetic division to find that quotient. I'll give you a minute before I start walking around to check. You can answer questions.